What is up, everybody? It is Simp again. We're doing some quadratic equations. So, before we get into anything, I'll just show you this thing. Bx plus c is equal to 0. And this is the standard form for a quadratic equation. There's the largest, 1a coefficient with an x squared power, and then there's a first power on the b term, and then just a constant x to the 0 c term. Usually if we want to solve quadratic equations or find the roots of a quadratic equations, what we have to do is we have to first get it into this kind of form in nearly every case. So I'm going to give you something, and it is a quadratic, but it is not in that standard form. So what we're going to do is get it to a standard form. So we have a 3 plus x times x minus 1 equals 5. My first instinct is to get this 5 on the left hand side, so you don't have to do that first, but negative 2 plus x times x minus 1 is equal to 0. And next I'm kind of seeing I want to multiply out this x times x minus 1, so let's do that. So the negative 2 stays, and then we just multiply this out, so this becomes x squared minus x. So after that, I think we're going to just move this constant over here just so that it looks a bit more familiar to this general form right here. So this thing is the standard form, and as we can see here, a is 1, b is negative 1, and c is negative 2. So if we want to find the roots to this, what we do is we have to think of two numbers that multiply to c, and then add to b. You've done this a lot. I'll just give you two numbers. If it's x squared, you're going to put an x and an x. If it's like a coefficient before that, I'll get into that later. So I immediately find two numbers, 1 and negative 2, that work, right? 1 times negative 2 is negative 2, and 1 minus 2 is negative 1. So these numbers work, so I'll just pop those in. Plus 1, negative 2. That is kind of sloppy, though. It'll have to do. Well, actually, it's not our final answer, because we'll put these all equal to 0, because we need to solve for x, right? So if I gave you something like ab is equal to 0, that's only true if a is equal to 0 or b is equal to 0, right? So it's the same thing here. We can just treat like these parenthesis terms as just a and b. We can set each term equal to 0. So x plus 1 equal to 0, x minus 2 equal to 0. And so x is negative 1 and x is positive 2. And that is now our answer. 2x squared plus 4x is equal to 30. My first instinct here, just divide everything by 2. I could do that. Maybe I will, but maybe I will. Let's just divide everything by 2. So we're dividing this by 2, we're dividing this by 2. So we get an x squared plus 2x is equal to 15. Why the heck not, right? So let's subtract 15 on both sides here. Subtract 15, equal to 0. So the other way you could do it, that's step 1. So x squared times negative 15 is negative 15x squared. Find two numbers that multiply to the product we just found, so negative 15x squared, but add up to the b term. So we have to come up with two numbers that add up to 2x, but multiply to negative 15x squared. And I can see two numbers immediately, and that's negative 3x plus 5x, because if you multiply them, it's negative 15x squared, but if you add them, it's plus 2x. So you can say that this is true, right? So negative 3x plus 5x is 2x. That's just the thing. So now what we can do is substitute your result in for the b term. So what I mean here is just go up here. Let's just rewrite this. X squared plus, instead of 2x now, we're going to replace it. So actually, let's get rid of that plus sign. It's going to be minus 3x plus 5x. Minus 15 is equal to 0. And now I'll just show you a little cool thing. If you group the first two terms and the last two terms, and then find the greatest common factor for both terms, the binomial that's left over is going to be the same. So what do I mean? The last step is to group them like I just did, the first two terms and then the last two, find the greatest common factor of each, and then find the GCF one more time. So here I can take out, I guess I can take out an x, so then we're left with an x minus 3 here, and then here I can take out a 5, so it's an x minus 3 again. So now you can see the x minus 3 is the greatest common factor, right? So obviously we are going to take the greatest common factor of this again, so it's going to be an x minus 3 out this time, which is the greatest common factor of this, and then we're just left with an x plus 5, and these are all equal to 0. And then the last step, I'm not even going to type it down because you know what happens. We're going to set each term equal to 0, like so. So x is going to be 3, or x is going to be negative 5, and that's how you solve quadratics. Equations, anyway. Inequalities, that's all a different thing.